Okay, hello and assalamualaikum. Today, me and my partner Alia will present about search trees and spanning trees. This topic is a subtopic from chapter trees and searching. So, this topic have two small topic, which is binary search tree and spanning tree. Before we proceed to the explanation, we will introduce ourselves first. So, my name is Nur Nabilah binti Roslan. My metric number is 202551, and I will present about binary search tree.
My name is Alia Maisara binti Rosman. My matrix number is 201084. I will present about spanning trees.
Okay, for the first small topic, which is binary search tree. This topic is about a graph. Basically, we'll call it as a tree which is a connected graph in which only one path exists between any two vertices of the graph, and the graph has no cycle, which is the graph will be not repeated. So I want to make you guys more understand about this small topic. So I will explain one question that will make you guys more understand about this topic. So for example, a question given draw a binary search tree with 14 nodes. So for the first step, you have to state number 1 until 14 in ascending order, like the picture show to you guys. So um for the first step, we have to find the root. For the root, we have their formula, which is L plus U divided by 2, which is L stand for lower and U stand for upper. This also known as floor function. So for the first step, L lower number is basically means the lowest number in the question. So in the question, the lowest number is 1. So we will take 1 as the lowest number. So for the upper number, which is the highest number in the question, so we will take 14 as the upper number. So we will include the number 1 and 14 in the formula, and we will get 7.5. So we have to make it as a whole number. So we will take 7, and for the first root, we get 7. So for the next step, the next step we will state another number 1 until 14, and we will circle the number 7 as the number 7 is the root for the first step that we just got. So basically, when we circle the number 7, we will have left subtrees and right subtrees. So from these two subtrees, we will find roots from them. So we will do as same as step 1, which is from left subtrees, the lower number is 1 and the upper number is 6. So we will take 1 and 6 and put it in the formula, and divided by 2, we will get 3.5. And that 3.5, we will take the whole number, which is 3. So the root for left subtrees is 3. So next, for the right subtrees, we will take, for the lower number, the lowest number we will take number 8, and the upper number we will take 14 as it is the highest number in the subtrees. So we will put it in the formula, and we will get 8 plus 14 divided by 2, and we will get 11, which is we will get 11 for the root. So for the next step, okay, basically when we from step 2, we will get 3 and 11 for the root. So we will repeat the step to get we will repeat the step until we cannot find the roots anymore. So when you see the third step, you will see that when we get 3 and 11, so we also have left subtree and right subtrees again. So we will do as same as the step 2, which is we will have for 3 we for 3 as the root, we will have left subtree and right subtree. So and for 11, for number 11 as the root, we will have left subtree and right subtree too. So for 3 as the root, we will have for the left subtree we will have 1. We will have 1 as lower and 2 as the upper. So 1 plus 2 over 2 equal to 1. For the right subtree we will have 4, and for the lower and upper and 6 for the upper. So we divide it, we will get 5. For 11 as the root, we will have 8 as the lower, and we will have 10 for the upper. So we will divide by 2, we will get 9. As the right subtree, we will have 12 as the lower and 14 as the upper, and we will divide by 2 to get 13. So for the next step, we will try to search for the other root, but we cannot find another roots anymore, as we get 1, 5, 9, and 13 as the final root for the question. So we will use the root that we get from step 1, step 2, step 3 to make a binary search tree. So next, this is the final answer. So we will put 7 in the middle of the tree. So 7, and we will divide it by 2 as we get to root for the step as we get to root in the step 2, which is 3 and 11. So from 3 and 11, in step 3 we get 1, 5, and 9, 13. So 1, 5. So for number 1 and number 5, we have to put it under number 3 because we get it from root number 3. And 9 and 13, we will put it under 11 because we get it from root 11. So from the root that we get, number 1, it have number 2, right? So we will put it under number 1. And basically we will put the number that did not have that did not make into the root under the number that basically whether it is left subtree or right subtree. So I hope you understand about binary search tree. So this is the final answer for the question that I given. So if you don't understand, you have to you can look back at the step that I just give you guys. So I will give Alia to explain her topic.
Okay. Now I will explain about spanning tree. It is actually a spanning tree. Spanning tree is a graph which contains all vertices with a minimum number of edges, and it is also known as a spanning subgraph and a tree. Yes. Okay. As we can see here, the first graph is the main graph. Okay, from this main graph, we can form not only one, but many spanning tree. The second graph is the first spanning tree from the main graph. We can take all the vertices, which is A, B, C, and D from the main graph and connect them all together. But from this spanning tree, we can see that the vertex B and vertex A do not connect to each other because it will form a cycle. The most important condition of spanning tree is it cannot form a cycle. So the third graph is the second spanning tree from the main graph. We can have all the vertices connect to the other one in many ways as long as it doesn't form a cycle, because the important condition of spanning tree is that it cannot form a cycle. Okay, we have condition for spanning tree, which the only condition is that it has to contain all vertices in the main graph, as I said before, and also we need to have the minimum number of edges. Okay, we have as we can see here, we have the formula for minimum number of edges, which is n minus 1, which each n is the total number of vertices. Okay, for example, if the number of vertices is 6, the minimum number of edges should be 6 minus 1 equal to 5. So the minimum number of edges should be only 5. Okay, besides that, we also have a minimum spanning tree. Means that a tree or a subgraph which has a total weight of the edges to be minimum. So the total weight of all edges should be minimum. Okay, for your information, all edges has their own cost or weight, and I have stated this a few times before that we need to remember not to form a cycle in a spanning tree. And that's okay. If we look at this example, we can see the weight of the edges in the main graph. Okay, the number beside the edges is actually the weight of the edges. Okay. So to form a minimum spanning tree, we need to know the number of minimum edges by using the formula n minus 1. Okay. Right here we have 4 vertices. So n minus 1, which n is 4. 4 equal to 1 equal 4 minus 1 equals to 3. So the minimum number of edges should be only 3. Okay. As 1 is the minimum weight, we should start to construct our spanning tree with 1. Okay. So 1 is the connection between vertex C and B. So we need to construct construct the edge that connect vertex C and D. Okay. The second one is with number 2, which is the connection of vertex A and B. Okay, right now we already have 2 edges, so we need the last one as because the minimum number of edges should be 3. So from the main graph, you can see that we have 2 edges with weight of 3. So the connection between vertex A and C cannot be used in constructing the spanning tree because it will form a cycle. So we take another edge with weight 3 because it will not form a cycle. Okay, so this right now we already have 3 edges. So our first minimum spanning tree is complete. Okay, next. Okay, the second example shows the total vertices of 6. So the minimum number of edges should be only 5 if we follow the formula. So As I explained earlier, we need to start to construct the spanning tree with minimum number of weight, which is 1. And from this main graph, it shows that two edges with two weight of 1. So we need to take them both because it doesn't form a cycle yet. Okay, so we need to take them both. And then the second weight is the connection between vertex A and B, as we can see from the main graph. Okay, and right now we see that there are 3 edges with the same weight of 3. So we need to reconsider the most important condition in forming spanning tree, which is not to form a cycle. So the only edge that doesn't form a cycle is the edge that connects vertex B and vertex F. And lastly, we take the connection between vertex F and vertex B because the other edge, which is edge that connects vertex A and F, will form a cycle. So right now we already have five edges, and therefore we have already completed our minimum spanning tree. Okay, I think that is all from us. Thank you.
Thank you.
I hope you understand what we were explaining just now. Thank you.
Thank you.